Okay, so we want to talk about this function and we want to find out where the function is increasing, where is it decreasing, where is it concave up or concave down. So a couple of things we have to get out the way. First off is um, our function is f of x equals to x to the third power minus 3x squared minus 9x minus 1. And a couple of facts we have to know going in is the derivative of the function, when that is greater than 0, you are increasing. When the derivative, the first derivative of the function is less than 0, you are decreasing. So that's the first thing we need to do is find the derivative so we can determine when it's increasing or decreasing. And then the second derivative of the function, when that is greater than 0, you are concave up. And when the second derivative is less than 0, you are concave down. So without graphing this function, we can determine the nature of this graph just by thinking about these different aspects in calculus. So first things first, let's take the derivative. So the derivative of the function, we bring the exponent down, we subtract 1 off the exponent, so it's 3x squared for the first term. Bring the exponent down, minus 6x to the first power. I don't write the 1. All right. Take the derivative of 9x, that's a 9, and take the derivative of negative 1, that's a 0, so it falls out of my problem. Okay, we're going to set that equal to 0, okay, and then we're going to find the algebraic solution of this equation. So 3x squared minus 6x minus 9 is equal to 0. I can first factor out of 3. X squared minus 2x minus a 3 is equal to 0. We can then divide out of 3 because it's no longer helpful for us. So x squared minus 2x minus 3 is equal to 0. And then we're going to factor. And if you're comfortable with factoring, I'm going to do it very quickly. All right, this is x and this is x. This is going to be a 3. This is going to be a 1 because 3 times 1 gives me a 3. And my numbers have to subtract to give me a 2, and I need a negative 2. So the bigger number has to be negative. The small number has to be positive. If you FOIL this out, you will get this in return, okay, if you do it properly. That means we have x minus 3 is equal to 0, and x plus 1 is equal to 0. We add 3 to both sides here, and we get x is equal to 3. We subtract 1 from both sides here, we get x is equal to negative 1. Okay, so all of that work to find out when are we increasing or decreasing. So I'm going to plot a number line. Sorry, I'm talking really fast because I got to squeeze all of this math into 5 minutes. All right, so I'm plotting a number line, and negative 1 is smaller than 3, so I'm going to put my negative 1 on my number line on the left, and I'm going to put my 3 on the right. Okay, and what I'm going to do is plot the function 3x squared minus 6x minus 9, which is the first derivative of the original function. Okay, so I'm going to do this very, very basic, right? So this is a positive leading coefficient number. So this is going to be an upward parabola. So my upward parabola is going to come down. It's going to hit the point right here on the x-axis where it is 0, where the value of the function is equal to 0. It's going to come down like parabolas do and go back up, hit the x-axis again at 3, and that's also a 0 for the quadratic function when it's graphed. All right, so these two dots are important. And why did I do this graphing? Because it tells me something very quickly. First off, I'm above the x-axis in this portion, so therefore I am positive, bigger than 0. I'm below the x-axis, negative here, and I'm above the x-axis here, so positive here. Positive, negative, positive. So now I can answer the question of when am I increasing or decreasing. When my first derivative is positive, I am increasing. When it's negative, I'm decreasing. So I am increasing on the interval from negative infinity to negative 1, union from 3 to infinity. And I am decreasing from in between those two, right? So in between negative 1 and 3. So you can see that from my plot. Okay, so I don't have enough time to talk about concave up and concave down. So what I'm going to do is I'm going to put another video, a second video, I'm going to attach it to this so that you can see the thought process for concave up and concave down. So you have to watch both videos to get the full answer for this problem. Take care.